we're going to learn how to multiply polynomials. This is not difficult if you will just remember that this is sort of an extended distributive property, okay? Where we've been distributing one thing to the polynomial. This time we're multiplying by 2x minus 3, so we've got to distribute the 2x and the negative 3. So let's look at that. First thing we're going to do is we're going to distribute the 2x. So we're going to do 2x times x squared. We get 2x cubed. 2x times negative 4x is negative 8x squared. And 2x times negative 5 is negative 10x. Then we're going to do the same thing, but we're going to distribute the negative 3. Negative 3 times x squared, negative 3x squared. Negative 3 times negative 4x is plus 12x. And negative 3 times negative 5 is plus 15. After you distribute, you look for like terms. So I have the 2x cubed. Nothing else is like terms, so I copy it. I have negative 8x squared and negative 3x squared. That's negative 11x squared. Negative 10x plus 12x is 2x, and the constant 15 just tags along. This next situation is multiplying two binomials. This one has two terms, this one has two terms. We're going to spend a lot of time with this later, but it's the same idea. We're going to take this 3x, we're going to distribute it. 3x times 2x is 6x squared. 3x times 5 is 15x. Then we're going to distribute the negative 2. Negative 2 times 2x is negative 4x. Negative 2 times 5 is negative 10. We're going to combine like terms. We end up with 6x squared. We have 15x minus 4x, which is 11x, and then the minus 10. So when we multiplied these two binomials, we get a trinomial. That often happens. We're going to see this a lot. Two binomials multiplied together give us a trinomial. This next one looks a little ugly, and we actually, like in class, won't see a whole lot like this, but they will show up on math team tests. They will show up on ciphering. So there's a couple things we want to talk about. First, let's just do the distributive property. First, we're going to distribute the y. Y times x cubed, yx cubed. Y times negative y cubed. Remember, when you multiply the same base, you add the exponents, so that's negative y to the fourth. Y times 2x squared y would be 2x squared y squared, and y times 3x squared y squared would be 3xy to the third. Now this one's going to be a little longer, so I'm going to go underneath for the second one. Now I'm going to distribute the positive 3x. Plus 3x times x cubed, b plus 3x to the fourth. 3x times negative y cubed would be negative 3xy cubed. 3x times 2y squared would be 6x cubed y. Y'all will have to check me as you go through this. And 3x times 3xy squared would be 9x squared y squared. Now, after you distribute, notice there's x's and y's everywhere. We're going to list in decreasing degree, decreasing, if I knew how to spell that, of x. So we're going to start with our highest x power. Notice I have a 3x to the fourth. So I'm going to list it first. It has no like terms, so it's done. Then we want to look for our x cubes. I see a yx cubed. There's a yx cubed. Multiplication is commutative, so those are the same thing, right? So 1x cubed y plus 6x cubed y would be plus 7x cubed y. Then I'm going to look for my x squared, so those are gone. 2x squared y squared, 9x squared y squared is 11x squared y squared. gone. Then I'm going to look for my x. I've got plus 3 xy cubed minus 3 xy cubed. Those cancel. And I'm left with that minus y to the fourth. Notice what happens here. This is not super important, but it does come up from time to time. My degree, my exponent of x is going down. X to the fourth, x cubed, x squared, my x canceled, and then there's not an x in this term, right? But then notice my y, my degree of y is going up. There's not a y here, then y squared, y cubed canceled, y to the fourth. Not a big deal, but sometimes you'll see where the exponents of one of the variable goes down while the other variable goes up.